This is Unit 5, right triangles. The infamous, the famous, the most important. Preview video 5.2, special right triangles. Sit tall. Close your eyes. In through the nose. Ready? Inhale. Hold. Nice and slow. You're going to need your finals review packet right in front of you. We're going to be talking about special right triangles. Now, as I've already hinted in class, right triangles are by far the most important shape you will ever study in geometry, by far. A second place would probably be circles, but right triangles. And the reason why right triangles are so important is they unlock our understanding of so many other things. This cardstock page in your reference booklet is the most important singular item in your reference booklet. That's why it's cardstock. You should actually hang on to it for literally years to come. In geometry, the key to the universe, it literally unlocks a multitude of things, is the right triangle. So this cardstock is called the Right Triangle Toolbox, and there's eventually going to be a total of 5 right triangle tools. And they are Pythagorean theorem, 45, 45, 90, 30, 60, 90, something called SOHCAHTOA, and inverse SOHCAHTOA. This cardstock in your reference booklet, I'm also going to not only call it the key to the universe, I'll call it your best friend, because learning how to navigate this cardstock will literally be like your best friend for this unit. Why are right triangles so important? They influence so many different kinds of professions, including, but not excluding anything, medicine, aviation, navigation, forensics. The obvious, any kind of architecture, green architecture, infrastructure, communications, and even ecology. Take a moment and check which one of these images most intrigue you about the connection of right triangles to that particular profession or concept. Just check what most interests you. This is probably not the first time you have been exposed to a right triangle, so I'm just going to quickly recap some vocabulary here. When you have a right triangle, you have a right angle. The two sides connected to the right angle are called the legs. The right angle, if you were, points to the longest side. It's like an arrow. That right angle points to the longest side. That's called the hypotenuse. And the most famous concept about right triangles is commonly called the Pythagorean theorem. Everything else we learn, according to right triangles, is actually somehow related. And what we learned in this is that the square of what's commonly called the A side plus the square of what's commonly called the B side equals C squared. A squared plus B squared equals C squared. But I warned you in class, I will never use that. Instead, I prefer this version of the Pythagorean theorem. If you take one leg and you square it, plus the other leg and you square it, and you can differentiate that with leg 1 and leg 2 if you want, equals the hypotenuse squared. That is my preferred version of the Pythagorean theorem. Leg squared plus leg squared equals hypo squared. Now, whenever you deal with the Pythagorean theorem, you're also going to be working with a lot of radicals. And it's important when you deal with exponents that you always expand the exponent. So when you're working with radicals, so when I have root 11 squared, you write it like this. If I have 3 root 7 squared, you expand it. Exponents, you expand. Anytime you see an exponent, you expand it. Root 11 times root 11 would technically be root 121, but that's perfect. So root 11 times root 11 is simply going to be 11. Any radical times itself is just the number on the inside. 3 root 7 squared is 3 times 3. Root 7 times root 7, which is just 7. 9 times 7. Last class, we learned this. If you have 2 sides and you need a third side, you pythag. It's your superpower. Have 2 sides, need a third side, pythag. Like Wonder Twins activate is the analogy. You pythag. It's your superpower. And the way we use that, we're going to do right down here. Step 1, always identify your legs and your hypo. So there's your right angle. There's our hypo. That's a leg. That's a leg. Write out your Pythagorean theorem. Always write out the equation. Always. Always. You're like, Miss Way, I know it. I don't care. You write it down. It creates a template. And then you circle, plug, chug. Watch. Leg, circle. It's root 10. Don't forget the square, so I put parentheses square. Leg, that's an x, x, parentheses squared. Hypo, I circle the hypo. 2 root 3, parentheses around that entire thing, squared. Exponents, expand. Root 10 times root 10 is simply 10. 2 times 2 is 4. Root 3 times root 3 is 3. 4 times 3, this is 12. Doing the light dance here. Solving for x. The opposite of squaring is square rooting, not divide by 2. So in this case, you can't factor x equals root 2. So we just have x equals root 2. Leg squared plus leg squared equals hypo squared. That's review. Let's quickly review our radicals here. 5 root 2 times what is 10? It has to be another root 2. Why? Because root 2 times root 2 is 2. 5 times 2 is 10. Root 3 times what is 9? I know I need another root 3. That gets us 3. What times 3 is 9? Another 3. So the correct answer for that box is 3 root 3. Root 2 times what is 1? You're like, now what? Well, I know I need at least a root 2 to cancel that radical. Root 2 times root 2 just gives us a 2. How do I get a 1? I divide by 2. That gets us 1. So root 2 times root 2 over 2 gets you 1. I like you to take 20 seconds and try to do this row by yourself. 20 seconds, go. If you're comfortable with this, 20 seconds should have been sufficient time. 6 root 2 times root 2 is 12, because root 2 times root 2 is 2. This is 7 root 3, because root 3 times root 3 is 3. 7 times 3, 21. This is going to be root 6 over 6. Exponent, expand. So 4 root 3 squared looks like this. Outies, innies. That's 16. That's 3. 16 times 3. 48. You've got 10 seconds to do that one on your own. Boom, let's check it out. 3 root 5, 3 root 5, outies, 9, innies, 5, 45. You got all that page correct? You have everything you need to be successful today. So we use the Pythagorean theorem when you have two sides and you need a third side. Have two sides, need a third side, Pythag. So let's solve this one together. We have two sides and we need a third side. We have two sides, 1, 2, and we need a third side. So we're going to Pythag, our superpower. Leg squared equals hypo squared. We're going to circle plug chug here. One leg is x squared. The other leg is 4 squared. And our hypo is 4 root 2 parentheses squared. Let's work this out. It's x squared, 16. In the margin, 4 root 2 times 4 root 2. 4 times 4 is 16. Root 2 times root 2 is 2. So 16 times 2, that's 32. We're going to minus 16 both sides. I get x squared equals 16. The opposite of squaring is square rooting. You're following along. And we have x equals 4. So come up here. We solve for x. X equals 4. That's Pythagorean theorem. Now today we're going to focus on what's called special right triangles. Special. There's a special case. And these two special right triangles have some shortcut patterns. And in this special circumstance, you only, instead of have two sides, need a third side, Pythag, you only need one side. And you can find two other sides with that one side using special patterns. And the special right triangles are specifically and only 45, 45, 90, also known as an isosceles right triangle, and 30 degrees, 60 degrees, 90 degrees. Triangles, 45, 45, 90, 30, 60, 90. That's it. These are called special right triangles. No other combos qualify as special right triangles because they have special patterns. We're going to try to discover those patterns right now. Ready? We're going to solve for x in both of these cases. So the left one, 4 squared plus 4 squared equals x squared. It's really important that you're very comfortable in simplifying, so we're going to break this down. And we have here one set of 2's are going to come out. Another set of 2's are going to come out. And then 1, 2 stays home. So when we solve for this, we're going to have 4 root 2. That's going to be our hypo, is 4 root 2. Now, let's do this one on the right. Again, we're dealing with only a 45, 45, 90 triangle. And one leg is 5 root 2. We're squaring. The other leg is our unknown this time. And our hypo is 10. Track with me. 5 root 2 times 5 root 2. Exponents expand. Outies, that's 25. Innies, that's 2. That's 25 times 2. That's 50. Subtract 50 both sides. Simplify. Fives can come out. Root 2 stays home. So the correct answer here is 5 root 2. Now, there are a couple patterns here, and I'm not going to tell you these patterns on this side. I really want you to do your best guess. I want you to take a very close look at this entire page. I'd like you to physically trace with me. Trace the legs. Trace the legs. Now, I'd like you to write a sentence in both cases. What do you notice about both legs? Write a sentence. Pause if you need to a minute to think about this. Second thing, I'd like you to take a look. What do you notice about that? Should be pattern from the leg to the hypo. So this leg to the hypo, I'm going from 4 to 4 root 2. Here I go 5 root 2 to 10. It's the same pattern. What's going on? It's kind of like a mystery. What happened from 4, and then we get 4 root 2, and then we have 5 root 2, and we get 10. It's the same pattern. I'd like you to try best guess. Best guess. Totally okay if you're wrong, but best guess. Write something down. What's going on there? I'm going to wait 10 seconds. Let's see what you noticed. Let's see what you noticed. Okay, the pattern was this in right triangles, in 45-45 right triangles. The legs are always going to be equal. The legs are equal, which they were in this case. I'm going to take this back. Take a look. The legs are equal. 4, 4, 5 root 2, 5 root 2. So that's the first pattern, is in a 45, 45, 90, the legs are always going to be equal. And then looking back here, from the leg to the hypo, look at what we did here. We went 4, and we ended up with 4 root 2. We had 5 root 2, and we ended up with 10. What changed from the leg to the hypo? It was the exact same change for both. And the exact same change for both was that you times by root 2. 4 times 4 root 2, 4 times root 2 is 4 root 2. 5 root 2 times root 2 is 10. So the pattern is the hypo is going to be whatever the leg is times root 2. That's the pattern. Look at the pattern here. The first pattern is that the legs are equal, always, in a 45, 45, 90. And the hypo is whatever the leg is times root 2. So 4 times root 2 gave us 4 root 2. 5 root 2 times root 2 gives us 10. So the pattern is this, folks. Ready? 45, 45, 90, leg, 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 root 2. Now that you got over the shock of a teacher chanting something, you're going to join me. Ready? Join me. 45, 45, 90, leg, 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 root 2. Again, 45, 45, 90, leg, 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 root 2. Many of you can get a lot better beat going on there, but it's the basic idea. Using this pattern, watch carefully. This is now a shortcut. When you have a 45, 45, 90 triangle, you don't have to use the Pythagorean theorem. It's a shortcut. Watch. Chant, touch, same time. 45, 45, 90, leg, 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 root 2. So step 1 is I mark the legs equal. Then, from either leg, since they're equal, you draw an arrow going to the hypo, and it's times by root 2. So we're going to solve for our variables, 45, 45, 90, leg, 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 root 2. So if this side is 3, guess what this side is? Ta-da! That's how hard that is. Leg, leg. Legs are equal in a 45, 45, 90. Why? 2 equal angles, 2 equal sides. 2 equal angles, 2 equal sides. The hypo is whatever the leg is times root 2. So guess what this is? 3 times root 2 is 3 root 2, folks. Yeah, that's how hard that is. Let's try a couple more. "45, 45, 90, leg, 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 root 2. 45, 45, 90, leg, 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 root 2. So this is how it reads. Our legs are the same, but they're both unknown. It reads like this. Something that is unknown, times root 2 is 8 root 2. Something times root 2 is 8 root 2. Something times root 2 is 8 root 2. Guess what the something is? 8. So here we would backtrack. What times root 2 is 8 root 2? The answer is 8. And since the legs are equal, your b is also 8. Let's try one more. And this is only for 45, 45, 90, folks. That's why we got to chant. It's special. It's what's called a special right triangle. 45, 45, 90. Leg, 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 root 2. 45, 45, 90. Leg, 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 root 2. So this reads something times root 2 is 10. A little bit trickier. You can see why we worked on those radicals. Something times root 2 is 10. The question is, what's the something? And in that box, we know we need a root 2 to get rid of that radical because somehow it disappeared. Root 2 times root 2 is 2. What times 2 is 10? 5. What's in the box? 5 root 2. What's over here? 5 root 2. All right. Students, you now have this page on your own. Pause the video. Do this page on your own. It should honestly take you about 30 seconds. And then restart. Pause the video. Ready? Welcome back. Let's check this out. 45, 45, 90, leg, 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 root 2. So your legs are equal. This should be 4 root 2 as well. 4 root 2 times root 2 is going to give you 8. Down here, 45, 45, 90, leg, 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 root 2. It reads like this. Something times root 2 is 6. What is that something? That something's going to be 3 root 2. Since the legs are equal, this should also be 3 root 2. I expect red pen corrections here, folks. So if you're correct, star smiley. You're not correct, write yourself a little note. What are you going to remember? Now, we had 2 special right triangles, 45, 45, 90 and 30, 60, 90. We're going to use the Pythagorean theorem to solve for both, and then you're going to notice some patterns. Hopefully, you'll notice some patterns. Ready? Just a quick note. Notice now the legs are no longer equal. We have a smaller angle, so this is the short leg. And we have a larger angle, so this is the long leg. The legs are no longer equal. Just note to self. If the angles are equal, the sides are equal. When the angles are not equal, they have different lengths. So one leg is 5 squared. We're solving for the hypo. Exponents expand. That's really important. You're in the habit of doing that. 5 times 5 is 25. Root 3 times root 3 is 3. 25 times 3, that's 75. So our hypo here is 10. So one of our triangles, it goes 5, short leg, 5 root 3, long leg, and then 10 for the hypo. Let's come over here and see what happened. This time we don't have the short leg. We're going to call this x squared. Our other leg is 6 squared. And our hypo is 4 root 3 parentheses squared. 4 times 4 is 16. Root 3 times root 3 is 3. 16 times 3, 48. So I have x squared equals 12. I square root. We're going to simplify, of course. And I get 4 and 3, 2 and 2. The 2 comes out. So I get 2 root 3. Take a very close look at this. So in this case, I get 2 root 3. There are 2 patterns going on here. It's the same pattern for both. Take a very close look at the pattern. Here's your first pattern I want you to pay attention to. What is going on between the short leg and the hypo? Short leg and the hypo. Here the short leg is 5, hypo's 10. Here the short leg is 2 root 3, the hypo is 4 root 3. It's the same pattern for both. Take 10 seconds. What's the pattern you notice? That's one pattern. Here's your second pattern. Between the short leg going to the long leg, this is 5, and the long leg is 5 root 3. 2 root 3, 6. It's the same pattern. 5, 5 root 3, 2 root 3, 6. What do you think is going on there? 10 seconds. Let's see if you correctly spotted the patterns. Correctly spotted the patterns. In a 30, 60, 90 triangle, here are the 2 patterns you should have noticed. 1, from the short leg to the hypo, you simply times by 2. 5, 10. Short leg to the hypo, times by 2. 2 root 3, 4 root 3. Short leg to the hypo, you times by 2. Short leg to long leg, you times by root 3. 5 times root 3 is 5 root 3. 2 root 3 times root 3 is 6. So short leg, hypo times by 2, short leg, long leg times by root 3. Everything goes back to the short leg. So here's the pattern you're going to write down. This is the one you're memorizing. In a 30, 60, 90 triangle, you have your short leg, whatever it is. Short leg to the long leg, you times by root 3. So the long leg is whatever the short leg is, times by root 3. Short leg going to the hypo, you times by 2. Short leg times 2. Everything goes back to the short leg. And 30, 60, 90, short leg root 3, short leg times 2. Sing with me. And 30, 60, 90, short leg root 3, short leg times 2. Get over your shock and sing it with me. 30, 60, 90, short leg root 3, short leg times 2. I'm having a hard time keeping the beat. One more time. 30, 60, 90, short leg root 3, short leg times 2. Let me show you what I mean. Let's do a couple together. Everything goes back to the short leg. So your first order of business is to find the short leg. So in a 30, 60, 90, the short leg is across the 30 because that's the smallest angle. So first I identify my short leg. I'm going to box it. I'm going to write SL for short leg. Everything sprouts from the short leg. I'm thinking of my head as the short leg, and we sprout like a couple branches. Short leg going to the long leg, we times by root 3. Short leg to the hypo, we times by 2. Everything starts with the short leg. So in this, I'm given the short leg, 3. So to get the long leg, it's 3 times root 3. Guess what that is? 3 root 3. And going this way, it's simply times by 2. So our hypo will be 6. Ta-da! That's it. You're done. 30, 60, 90. Ready? Over here. 30, 60, 90. Short leg, root 3 going towards the long leg, short leg towards the hypo times by 2. So it's really important I correctly identify the hypo. The hypo is times by 2. And the hypo is always across from the right angle. Now this one, you aren't given the short leg. You have to kind of work backwards. So it reads like this. Something times root 3 is 6 root 3. Let's bring it down here. Something times root 3 is 6 root 3. Something times root 3 is 6 root 3. Guess what the something is? 6. Ta-da! 6 times root 3 is 6 root 3. Then you times by 2 to go to the hypo, 12. That's all, folks. We'll try a couple more together, and then I'll cut you loose. Ready? 30, 60, 90. Short leg, root 3 going towards the long leg. Short leg times 2 going towards the hypo. Always identify your hypo. There's your hypo. So it reads like this. Something times root 3 is 6. You're like, that's a little different than what we just did. Something times root 3 is 6. What is our something? I know I need a root 3. That gets us 3. What times 3 is 6? 2. So the correct answer for y is 2 root 3. And when I times this by 2, only the outies talk to each other. So 2 times 2, this is 4 root 3. Let's try another one. 30, 60, 90. Identify your short leg. There it is. Short leg. Going towards the long leg, times by root 3. Going towards the hypo, times by 2. It reads like this. Something times root 3 is 3. Something times root 3 is 3. What is that something? It's root 3, folks. So the answer for y is root 3, because root 3 times root 3 is 3. Ta-da, you're done. And then you simply times by 2. Guess what this is? 2 root 3. Alrighty, this you're going to do on your own using that same pattern right here. Should take you about a minute, and then we're going to check your work. So pause the video. Welcome back. Let's check your work. 30, 60, 90, short leg, root 3, short leg times 2. So your short leg was 6, your long leg is 6 root 3, which is the value for y, and 6 times 2, x, which is the hypo, is therefore 12. 30, 60, 90, short leg, short leg root 3, short leg times 2. So we had to work backwards. What times root 3 is 4 root 3? Our V here should be 4. And 4 times 2 is 8. Once you see this pattern, it's pretty easy to work with. 30, 60, 90, short leg, root 3 going towards the long leg, and then short leg times 2 for the hypo. Reads like this. Something times root 3 is 9. What's our something? Your something here is 3 root 3. Times 2, that's going to be 6 root 3. Check your work. You're correct. Big star smiley. Wow, you're brilliant. You missed something, write yourself a note so you don't forget. All right, students, there's 2 more things you have to do. Take just one minute, I'm show one finger, 1 minute, and just bullet point what's the 3 main things you want to remember from today in your own words. Then, to streamline my grading, you're going to go back and you're going to take photos of every single page, just real quick with your iPad, starting with page 4, which is right here, page 4. Take a photo, take a photo, take a photo, take a photo, take a photo of each page right here, and you're going to be loading it to ClassKick. Individual pages. Let me show you what that looks like. In ClassKick, I gave you a code. And when you enter this code, you're going to get a slide that looks like this, and you're going to load your photos of each page, 1 photo on each page. It'll streamline the grading. Good luck.